Hi class, it's your TA Trevor. But instead of talking to you about trees, we're going to be talking about plot establishment and what that means for vegetation ecology. Plots are really important for capturing what vegetation exists on the landscape. And the important thing to consider when you're setting up plots is the scale. So how big of a plot do you want? It's sort of dependent on what kind of questions you're trying to answer. So there's not really a right answer, but I'm sure we'll talk about this more in class. Before you even get out into the field to start a plot, it's really important to wear the right materials and wear the right clothes. So I've got a good pair of sturdy boots, some nice thick Carhartt pants, a trusty tree belt buckle, a nice flannel, and a good hat. All right, let's start looking at plots. All right, so when we're starting to set up a plot, the first thing that we're going to do is take a chaining pin. We're going to put it into the ground. Oh, there's some rocky soil. And we're going to take one of our 20-meter long tapes. We're going to put it down and we're going to run it out to 20 meters. And once it's out to 20 meters, we're going to record what azimuth it runs along, which I will show you what that is in just a second. So we'll set that up.
Hi class, it's your other TA, Alice. So I'm going to describe to you how we get the bearings for this first line of our transect, and then can use that bearing to make a 90-degree angle for the second side of our transect. So to do that, we're using a compass. And to do this, first we want to make sure that red Fred is in the red shed. So this red arrow is pointing to magnetic north. We want to make sure that red Fred goes into his house, the red shed. And that if red Fred is in the red shed, then we know that the compass is pointing north. And then what we do is we line up the compass with the direction of the tape. And we can use this mirror at the top to sort of sight it in, making sure that we're keeping red Fred in the red shed. Well, first we line up the compass with the tape. You can't really tell in the video, but we're attempting to line up the compass with the tape. And it is lined up, it's just sort of hard to tell. And then we move the compass a little bit so that red Fred is in the red shed. Okay, and now we can look at, this little arrow, or this little marking right here. And we want to see where on this dial, which number that little marking is lining up to. And so we can see here it's lined up to 18. And so that means that the bearing of this tape is 18 degrees. All right, so a couple other things to mention that are important when you're setting a plot. The first is to keep your tapes as straight as possible, so that they're in a straight line. They're not going, up and down and over and under things. Sometimes, that's unavoidable, but you want to avoid that as much as possible, because that can alter the distance measurements that you're getting. All right, so now we're ready to figure out which bearing we're going to use to set up our second tape. So because we're making a square, or a rectangle rather, we want each of the corners to be 90 degrees. And so we know that this first line, this first tape, it is along a bearing of 18 degrees. And so then, basically by subtracting 90, we can figure out the bearing for this second tape. It's complicated by the fact that, so we have this circle, which is 360 degrees. And so because we're going from right to left, we have to do some funky math. So we want to know if we've gone to the left 18 degrees, then 90 minus 18 is 72, and 360. So then we're subtracting 72 from 360 to get our correct bearing for our second tape. And so 360 minus 72 is
288.
288. Right, 288. You can't think when you're on video. Okay, so then what we're going to do, we're going to turn the dial on this compass until the number 288 lines up with this little marking. There we go. And each of these little hash marks is 2. So 280, 82, 4, 6, 8, 90. So 288 is lined up. And now, again, so I'm going to be standing right over the chaining pin at the corner, and I'm just going to move the compass until Red Fred is in the red shed. And then I'll know that this little marker is now pointing in the direction we want to go. And so then we'll have Trevor attach a tape to this chaining pin at the corner, and I will tell him as he stretches it out whether he's going in the correct direction. And to help aid this, I can actually look. So as long as I'm standing over the chaining pin, I can hold the compass and actually look in there and use this mirror to make sure that we are going in the right direction.
Okie doke, so now that we've got our plot set up, we did one 20-meter transect this way, a 50-meter transect going up, and then we repeated the process to make it a rectangle. We need to measure plants within the transect, and so the best way to do that, and the way that we're going to be doing that, is through a couple of different methods. We're going to be using point line intercept, which involves using a pin flag, and dropping the pin flag at every half meter for the length of this 50-meter transect. And we drop it, and then we record what that pin flag touches. So for here, it's only touching litter and bare ground. But say, for example, we dropped it right here and it touched this plant. We would record that it is touching a graminoid, and then it is touching the litter. Whereas this would be a forb or a shrub. And we would just write those down, and we'd make a tally on our data sheets, which I can show you here. And we tally, and we do this when we're on the transect. We always do this where we're outside of the transect and we're dropping the pin flag on the inside of the transect. So when you're facing up the transect, it's on the left side that we are, and we're dropping it on the right side. Always make sure to collect data inside the transect. So the next method that we will be using for understory plants is using quadrats. This one is about 1/2 meter by 1/2 meter to record relative cover within. So we go to every 5 meters, we collect and we drop our transect down, and we record the relative cover of what's inside the transect. So this is a pretty easy transect. It's all Juniperus communis, common juniper. And we would record that, oh wow, this is mostly common juniper, so I would say for this, it's about 95%. Sometimes we use individual covers and we go to the closest that we can. Other times we use cover classes. And then we repeat this again every 5 meters, recording the cover within this quadrat. So here's another example. This isn't where we would lay the transect out, but it's just an interesting case of what could happen. When we lay the transect also, it's important to keep the transect square. Say we were going to lay the transect at 3.5 meters. We would line up the corner with 3.5 meters, make sure the base of the transect lines up with the base of the quadrat, and then we would look at this area right here, and we'd look at the cover of Pascopyrum smithii and
Gutierrezia cerothrae, I think, and something else. Heterotheca villosa, I think, and some little Agaceris leaves, perhaps.
Ooh, yeah, maybe some.
To do some forensic botany.
Yeah. Anyway, so we'd look at that and we would determine what's going on in the quadrat, and then we'd write that down, make a tally, and then we would do this both for this side and the mirror image side of the transect that we have laid out. We would also do that for the point line intercept method. So in addition to these understory measurements, we would also collect diameter at breast height for all of the trees within the plot. So refer to those videos to determine how to collect diameter at breast height appropriately within a plot.